Hi Aaron, today we're gonna solve the lead code problem 875, Coco eating bananas. Let's read the description. Coco loves to eat bananas. There are n piles of bananas. The ice pile has piles I bananas. The guards have gone and will come back in 8 hours. Coco can decide her bananas per hour eating speed of K. Each hour she chooses a pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco loves to eat slowly but still wants to finish eating all the bananas before the guards return. And we will return the minimum integer K such that she can eat all the bananas within 8 hours. Okay, so this description is kind of long, and at the beginning we have no idea what kind of method we're gonna choose, but we notice that for this problem we have an array, and also the requirement is to return a minimum integer. And it seems like there is a function in this description, and we will find something about the function. So for the array problem, and it seems like there is a function, and we think about the binary search. So why we think about the binary search? So for traditional binary search, if binary search, we use that to solve the problem that in an ordered array we want to find a target and we want to return the index of it. And also it's possible that if an array that we have multiple target in it and they are together, and therefore we want to find the leftmost target, the index of it, or the rightmost target, the index of that. We have solved a lot of binary search problems about that. So in a concrete algorithm problem, it's possible that in two scenarios we're gonna search the binary, left binary, and also search the right binary. It's very rarely that we wanna search a concrete one element. So because for the algorithm problems, normally we're gonna like minimum and or maximum. So it's like for example, for this problem, it's like we wanted to find a minimum speed, and also in other problem, it's possible that we wanna find a minimum number of something, a minimum speed, minimum quality. So for this kind of algorithm problem, we're gonna use the binary search to search the boundary. Okay, so let's say this. So for algorithm problem, there is a scenario we can use a binary search, and it can satisfy the following conditions. And the first one is the fx must be a monotonic function with respect to x. It can be monotonically increasing or monotonically decreasing. And the second condition is that the task is to calculate the value of x when the constraint fx is equal to target is satisfied. So therefore, we're gonna draw a function like this. It's kind of very abstract, but we know that we're gonna have some imagination, and it will give us a function like this, and fx, and the target is something. Okay, so for this problem, we're gonna draw what is the target, what is the return value we want to get. So return value is a minimum integer x, an integer k, so that she can eat all the bananas within 8 hours. So therefore, the speed will be the x, and the time will be the fx, the y. So we're gonna draw an image like this, and obviously if we wanted to find the minimum integer, we're gonna return the left point of that. So therefore, we can say it in the picture. So let's say the code. So we gonna write a function. It's about the hours and the speed. So we will have the input speed, and we're gonna also input the pals, the array, and we're gonna return the hour of the according speed. And for this problem, obviously it's like a function about the speed, and it will return the hour. And we're gonna pay a special notation here. Special attention here is that we are using long instead of int. So why is it? Because if we look at the conditions, we'll notice that the pals, the length, is smaller than 10 to the power of 4, and the pals I is smaller to 10 to the power of 9. Therefore, if it's possible that the speed is 1 here, it's possible that hours will become 10 to the power of 13, and the maximum int is like 2. It's not that large. It's like 2 times 10 to the power 9. So therefore, we're gonna use a long here just in case we're gonna have the potential occurrence of integer overflow problem. And in the main function, we notice that we are using the we set the boundary. We set the value where we want to find this the speed. So it's left is equal to 1 and right is equal to 10 to the power of 9. And in the while conditions, we're gonna have mid, and we have this one. We're gonna use binary search here, and just pay a special notation about how we move the left and right. We have studied this before, but pay special notation about we are using the function we write in the conditions. We are using that to help us to make judgment. And at the end, if we think about the time complexity, it will be big O of n times log m, and n is the length of the pulse array, and m is the maximum pulse size. So because we are using binary search to find the minimum eating speed, and the binary search will take the log m, and each binary search it takes big O of n to calculate the total hours using the hour method. So therefore, the overall time complexity will be big O of n times log m, and the space complexity will be big O of 1.